NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report. What you're seeing are vortices, tornado-like patterns of air generated by planes, made visible here by colored smoke as the plane flies by. They present a problem to other aircraft, especially during takeoff and landing. Wake turbulence has been recognized as a hazard for many years. The problem has become more critical recently as larger and more powerful jet planes take to the air. The danger of the swirling air masses is multiplied because they occur unexpectedly and the pilot of an airplane cannot see them. This animation shows the cylindrical masses of air as they whip around the wingtips of a plane, causing vortices. These Federal Aviation Agency wind tunnel tests further illustrate the way a vortex forms. How violent the turbulence will be depends on the plane's weight and speed. The air turbulence caused by vortices has been observed lingering on for several minutes after a plane passes by. NASA is approaching the problem first by trying to better understand the vortex phenomenon. At the Flight Research Center in California, a plane trails a larger aircraft to experience and study vortices in flight. Other engineers are looking at various wing designs and modifications in an attempt to break up the vortices before they occur. Marshall Space Flight Center researchers in Huntsville, Alabama, are trying to adapt laser technology to remotely monitor the invisible vortices in terminal areas. The laser provides a radar-like system that sweeps the sky and can see where the whirlwinds of air are located. The vortex churned up by this airplane as it flies by a smoke tower is spotted by laser and becomes a readable pattern that engineers can measure and record. The results of these various research programs are expected to provide a better understanding of vortices and make airport operations safer and more effective. Galaxies. Before the year 1900, few people knew what they were. We now know that galaxies are the largest single accumulation of stars in the universe. Each galaxy is a stellar system, separate and apart from all others. Many people study these unique star clusters through powerful telescopes. At NASA's Langley Research Center in Virginia, Dr. Frank Hole uses computers to learn how galaxies evolve. Any number of stars from 50,000 to 1,000,000 can be programmed into computers in disc-like circular structures. Computer cards are made and fed into a punch card machine. The readout is then transferred to tape and printed on paper showing a still picture-like image of the galaxy being simulated. At the same time, another machine prints out the star patterns in numerical form. It is also displayed visually and recorded on film. Here are scenes showing how the simulated galaxies finally look on film. With all these various types of information in hand, scientists can then determine how a specific galaxy forms, learning more about the universe, and maybe eventually catching glimpses of the early stages of time. This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.